ACI, the Network Made Simple learning series. In this video, we will cover Module 3.1, Configuring Logical Connectivity in the Cloud, Chapter 4, From Zero to Networking in AWS using Cloud ACI. In the previous chapter, we talked about Cloud ACI and how it can help organizations integrating or migrating to the cloud faster, providing a single provisioning and operational model for networking services, with embedded automation and consistent security without sacrificing any cloud-native services. Let's now learn how to deploy and configure Cloud ACI on AWS starting from zero. Our scenario for today is simple. We want to connect a web server instance to a database instance, both running on AWS and only allowing ICMP and HTTP traffic between them. I will also need to provide internet access to my web server instance since I will want to connect to it via SSH directly from my laptop. Are you ready? Let's get started then. We will take three main steps to achieve our goal using Cloud ACI on AWS. 1. We will subscribe to the Cloud APIC service. 2. We will run the initial setup wizard. And 3. We will configure the logical network just as we know it already. I will take you through all these steps to achieve connectivity. But before we get started with the configuration, there are some prerequisites we need to follow. We will need at least 2 AWS accounts. The first one will be used for our infra tenant, and we will need to make sure that we have at least 9 elastic IP addresses so that we can successfully deploy any scenario, whether hub and spoke topologies based on CSR 1000Vs, which require 4 public IPs to be deployed, or transit gateways as the preferred deployment model. You can easily check if your current quota meets the requirement by going into your AWS console, clicking on EC2, and then Limits. If you search for your elastic IP address limits, you should see that the default is 5. So, if you need it, just request a limit increase to at least 9, providing a description for your request, and then click Submit. After a few minutes, you should get an email with your case ID granting your elastic IP increase. And you can confirm this by refreshing your console, which should display the new value. The next thing we need to make sure exists before we get started is a key pair. As we learned before, you just have to go to EC2 and in the key pair section, create a key pair and save the .pem file. And last, if you're thinking about using hub and spoke topologies with CSR and BGWs, or interconnecting to other clouds or on-prem environments, you will need to subscribe to the CSR 1000V service so that Cloud APIC can automatically deploy it. Just go to AWS Marketplace. And once you're there, you will need to search for Cisco CSR 1000. Once you select it, click on Continue to subscribe, and finally accept the terms. That's it. Then, just remember that each tenant you create in Cloud ACI on AWS will be a different account. Once we have all the prerequisites met, let's subscribe to the Cloud ACI service. Remember that Cloud APIC will run as an EC2 instance on AWS. In order to accomplish this, we will do 3 simple steps. 1. We will subscribe to the service in the marketplace. 2. We will adjust the Cloud APIC settings. And 3. We will let the automated CloudFormation template do the rest. Let's start with 1 then. Simply go to the marketplace and search for Cisco APIC. Click on it and click on Continue to subscribe. Accept the terms and continue to the configuration. We will now choose the region where we want this Cloud APIC instance to run on. In my case, I will choose US East, then I will click Launch, and then Launch CloudFormation. The CloudFormation template is automatically loaded as you can see, so just click Next and then let's adjust the deployment settings. First, add a name to the deployment. It can be anything you want. Then, you may leave the defaults or adjust. I will just leave the defaults, but please keep in mind that if you're planning to integrate hybrid or multi-cloud environments, the infra network should not overlap with your on-prem VTEP pools or other Cloud APIC infra pools. Then, adjust your availability zone if needed. Choose a password and select the SSH key pair we just created. Finally, provide the network where you want this APIC to be accessible from, which in my case will be 000/0, just to allow access from anywhere. Click Next, accept the terms, and finally click on Create Stack. You will see multiple things getting automatically created by the CloudFormation template as we covered before. Once the status changes to create complete, go into EC2, click on Instances, and you should see that your Cloud APIC has been automatically provisioned. You can now copy the public IP address from it and paste it on your browser to have access. Cloud APIC is now running, and all its necessary cloud constructs were automatically created. If you go into your AWS console in your infra account, you can see that in the VPC section, a VPC called Overlay1 was automatically created, including your defined infrastructure IP address pool and routing table. A few subnets were also created and attached to the routing table that was just created. An IGW was also created and attached to the VPC to allow internet access to our Cloud APIC, and the APIC security groups allowing SSH, HTTPS, and ICMP inbound were created as well. After APIC is up and running, let's now log in and run the initial configuration wizard with 3 simple steps. In the first one, we will simply set the DNS and NTP server. In the second one, we will select the AWS region or regions we want this Cloud APIC to manage. And in the third one, we will add the corresponding licenses if we have them. Otherwise, we'll simply leave the trial version running. Let's start by logging into our Cloud APIC with our defined credentials, and in the welcome screen, click on Begin First Time Setup. Click on DNS and NTP server and adjust your parameters as needed. Then, we will go to the region management section. But before we choose which regions we want to manage, let's first cover a few concepts applicable to region management and how ACI implements it. As we mentioned before, we will first choose which connectivity method we want to use for inter-VPC traffic, whether hub and spoke with CSR1000Vs and BGWs, or transit gateways. If you choose transit gateways, ACI will automatically create a couple of TGWs on each region you select, only in the infra account. This is known in ACI as the Transit Gateway Hub Network. As you may remember, transit gateways will require an autonomous system number, so we will need to specify one. All the tenants you create in Cloud ACI will use and attach to these common transit gateways to communicate. Now, if you choose to run CSR1000Vs and VGWs instead, Cloud ACI will automate the deployment of at least 2 CSRs in a specific region. All the different tenant VPCs will communicate through them through an automatically provisioned VGW. ACI will take care of all the necessary IPsec tunnel setup and routes. If you decide to run CSR1000Vs on one location only, and you have different tenants on different locations, keep in mind that inter-VPC traffic in a given region may have to travel all the way to the hub region. Therefore, although optional, it is recommended that you consider the deployment of additional CSR1000V pairs, wherever needed, to optimize traffic forwarding. If you choose Transit Gateway, remember that you may also choose to deploy CSR1000Vs for hybrid cloud and multi-cloud purposes. Let's go back to Cloud APIC and choose our options now that we know them. Our Cloud APIC is deployed in the US East region, and we will be using transit gateways as our default inter-VPC connectivity model. Then, there are 3 boxes we can check. The first one should be enabled if we want to deploy CSR1000Vs in a specific region. The second one should be checked if we're planning to interconnect to other clouds or on-premises environments, and the third one refers to enabling transit gateway statistics. From here, we can choose additional regions to manage, and you may enable any of the previously covered checkboxes as well. As you can see now, we already have a subnet pool for our CSR cloud routers. This value was taken from our deployment settings, and will be used to assign internal IPs to CSR1000V interfaces. If we choose to run hub and spoke topologies, and we want to enable additional regions, keep in mind that you will need to add separate subnets for each additional region. Now, we'll assign our Transit Gateway BGP autonomous system, and since I chose to deploy CSR1000Vs for multi-cloud connectivity purposes in my US East region, I will also assign a BGP autonomous system to them, as well as a username, password, and desired throughput. Remember that if you choose a higher throughput, Cloud APIC will deploy a larger EC2 instance for you, which may increase your overall cost. If you have a license token, place it here. Otherwise, we will go with the trial and finish our initial setup configuration. As a result, there were multiple objects automatically deployed in our AWS infra account. If we take a look at EC2, we can see a couple of CSR1000Vs running, and if we go to the VPC section, you will also see a couple of transit gateways instance with the autonomous system number we defined. All set. We are now ready to start configuring the logical network just as we learned. Therefore, join me in part 2 of this video where we will create a few instances and simply connect them through Cloud ACI.